Yeah, this video is to go over homework for homework packet 4A. Let's look at problem number 5 on lesson 6.02. So it says 3 of the following pairs of numbers have the same geometric mean. Which pair has a geometric mean that is different? So the goal is to find a pair that has different geometric mean for other 3 pairs. So let's think about what the geometric means first. So geometric mean is you take 2 numbers, right? Let's say you have 2 numbers. You multiply them and take a square root. That's the geometric mean. While arithmetic mean is the one that you know, which is if you have 2 numbers, you add them and then divide by 2. So let's look at part A. Says, well, choice A says 2 and 72. What is the geometric mean of it? So you take those 2 numbers and multiply them. That gives you 144. And then take a square root of 144. That gives you plus or minus 12. Right? Or just 12. Okay. So, find the geometric for part B, choice B, choice C, choice D to see if which one has different geometric mean. And the one that is different is the answer. Now let's go to lesson 6.3, which is page 3. Let's look at problem number 6. So you have a triangle. It says, goes something like this. And what's given? What's given is RT, segment RT, is hypotenuse of triangle RST. RU is 2 and UT is 6, and we know these are right triangles. And we have to find the value of y and x using the concept of similarity. Oops, what happened? So, let me make it a little bigger. Okay. So now let's look at this. So first thing we want to do is we want to compare, do you see 3 triangles? One small one, this guy, and one medium one, and one big one, right? So we're going to draw those 3 things. So one small one goes U here, and S and R. Medium one will be, you see I'm drawing in the same orientation so that it's not confusing. S-U-T, and then the big one has T-R-S. And these are the right triangles, right? So you might remember that these 3 are all similar triangles from chapter, maybe 2 or 3. So I'm just going to draw everything that I know. So RU is 2. Do I have RU? No. How about UT? UT is 6. And then we just want to find out what the Y is, which is RS, and also TS, which is this guy. Right? Okay. Oh, I also know that RT right here is 8. See that? 2 plus 6 is 8. Okay, so let's look at this and figure out what the S and R is. Oh, wait a minute. This RS right there is also Y right here. You realize that? So maybe we don't really need the one in the middle because we already know the other thing. So let's just eliminate it. And let's look at the relationship. So 2 times something is y, and y times something is 8, right? What are those numbers? 2 times y is something, right? 2 times some number, let's say k. So 2 times some number k must be y, and y times some number k must be 8. So what are the k's? So let's look at this and let's solve it, right? So we know this y is 2k. So I'm going to replace this y with this 2k. Now we'll have, instead of y, we have 2k. So we go 2k times k, which equals 8. That means we have k squared, 2k squared equals 8. Dividing both sides by 2, we'll get k squared equals 4. Therefore, k is 2. Right? So 2 times this 2, k, which is 2, is y. What is y, right? Or this y times 2 is 8. What are the y's? Once you find the y's, right, you can use Pythagorean theorem to find the x. Okay. Moving on to page 6 on lesson 6.4, problem number 6. All right. So we have triangles, ABC. And now we have median. So let's take midpoints. Do you remember what the median is? Draw a line to the vertex. That's median P, median CM. And let's take point P somewhere on that median and draw a line. Okay? First one says draw the altitude from P for triangle APM, which is kind of the slanted one, and also BPM. How would you draw a altitude? Altitude is the height of the triangle, right? So how would you draw the height of the height for BPM? Well, it's just this one, isn't it? Right? How about the height of APM? It's exactly the same thing. So I'm giving out the answer for part A. B says complete the following statements and justify your answer. So it says triangle AP, area of triangle APC is equal to area of triangle ACM minus some area of triangle something. So the area of this guy, right, is this big triangle minus some triangle. Which one is it, right? And also you can solve that the same way for BPC as well. Oh, I did a mistake. This is not what they're talking about. See? So APC is this guy, sorry. This area of this triangle is area of ACM minus something. Triangle something. What is it? Okay? Once you get that, I think you can do the rest of it.